Lesson 6.6 is solving systems of linear inequalities. Up to this point we've done systems of linear equations where we found that we could have one solution where the lines intersect, no solutions if the lines are parallel, and infinitely many solutions if the lines happen to be the same line. But here we're going to look at linear inequalities. So this is going to require, again, the dashed line or the solid line, the shading above or below, left, right, etc. So let's go ahead and start filling this in. A blank, which is a system of linear inequalities in two variables, or simply a system of inequalities, consists of two or more linear inequalities in the same variables. For example, we have x minus y is greater than 7, 2x plus y is less than 8. We would end up graphing these out, and then I'll explain to you how you find the solution. A solution of a system of linear inequalities is an ordered pair that's a solution of each inequality in the system. So again, it's an ordered pair. Here's an example of 6, negative 5, and that would work in both of these inequalities above. If I put in 6, negative 5, I would have a 6 subtract negative 5 is greater than 7 for this first one. So we add the opposite, which makes 11 greater than 7, so it works here. And in the second inequality, I would have 2 times 6 plus negative 5 has to be less than 8. Well, 2 times 6 is 12, plus negative 5 less than 8, and that's 7, which is less than 8, so it checks out. So the thing about inequalities, though, is there are many solutions. So it's not just a single solution. This is an example of one solution. So the graph of a system of linear inequalities is the graph of all solutions of the system. So the way that we end up answering the question, what is the solution, is we do it with graphing. So when we graph them, step one is that you are going to actually graph each inequality, and then after you have them both graphed, you're going to find the intersection of the half planes. So this will require double shading, sometimes triple shading if we have more than one or more than two inequalities in our system. So let's go ahead and try this. The first type of problem that you're going to encounter in your assignment, they're going to ask you to tell whether the ordered pair is a solution of the system. To be a solution of the system, if the lines are solid, it could be on one of the solid lines as long as it's within the shaded region of the solid line, so here, or anywhere where they have the shading. They ended up erasing the shading that didn't overlap, so you can't really tell by the picture that there's a double shade here. So I look at the point 0, 1. It's right here. That is not in the shaded region, and it's not on the line that is adjacent to the shaded region, so your answer is simply no. And here I look at 0, negative 1. Well, unfortunately, it's on the dashed line. If it was on the solid line like 0, 1, that'd be a yes, but here again it's a no. And 1, 4 is a yes because it's on the solid line that's adjacent to the shaded region. Any of these points actually out in the shaded region are solutions. So any of these also are solutions. Alright, now we're going to actually do some graphing. So the first thing when we graph, you know that we have to put it in slope-intercept form. So up here I'm going to have y is less than negative 3x. When I do that, my y-intercept is 0. My slope is negative 3, so up 3 to the left one or down 3 to the right one. I look at the inequality sign. It does not have an equal sign, so it's going to be a dashed line. So I'll go ahead and graph this with my dashed line here, and I have to decide where to shade it. When I shade this, remember you can check 0, 0, except here I can't check 0, 0, so I could check a point in either of these half planes to see if it works, or I want you to try to get used to this. This is less than. If I'm graphing less than in reference to the line, I'm graphing what appears to be the left or below the line, or shading there. So my shade is going to become all of this area right in here. And I'll just shade that in. Good enough. Okay, the next one, I'm going to go ahead and subtract the 4x, so I get a negative y is less than or equal to negative 4x plus 1 divided by the negative, but remember with an inequality that requires you to flip the inequality sign. So y is actually greater than or equal to positive 4x minus 1. So my y-intercept is negative 1. My slope is positive 4x, so 1, 2, 3, 4, and up 1, 1, 2, 3. I can't go any further. Here, this is a solid line because it does have the equal sign under it. So I'll just drag through here. And in this particular one, it's greater than. So when it's greater than, you shade to the right, or what appears to be above. Well, I guess above the line is going to be right here. Maybe we should check a point to make sure that you get it. 0, 0 is not part of this, so if I check 0, 0, I'm going to end up with 0 is greater than or equal to negative 1. That's true. So I'm going to shade in this portion right here. I'm going to change my color. So this whole part here gets shaded, and where I have the double shade right here, this is my final answer. It really depends on how you want to do it. If you want to be like the book, you can erase this portion right in here where there's not the double shade, and you just get the one section of shading. What I do, honestly, I don't like to erase if I can help it. I just end up showing where my double shade is. Let's try another one. This one right here actually has 3 inequalities. So if I have x is greater than negative 2, again it's going to be dashed. Greater than negative 2. This is a vertical line. So here's my negative 2. It's greater than. And if you want to check 0, 0, you're more than welcome to, but 0 is greater than negative 2. And then I'm going to thicken this up just a little bit. Y is greater than negative 3. So right down here, oops, I thickened up. There we go. Y is greater than, well, I guess I don't really need to be that thick, but it's good enough. So y is greater than negative 3. So 0 is greater than negative 3, so I'll shade above. So all right in here. So far, hopefully you can see my double shading is right in here, this whole area right in here. And then finally, I have y is less than or equal to 3/4 x plus 2. So I have a y-intercept of 2, and my slope is 3/4. I can't go up, I don't have enough room, but 1, 2, 3, 1, 2, 3, 4. This one is a solid line. So right here. And then my triple shade, this is less than. If you check it out, you're going to end up with 0 is less than or equal to 2, which is false. I mean true, sorry. 0 is less than or equal to 2. So I would end up shading below. So I'm really only interested in the part below that already has the double shade, and that's going to be right in here. So here, this whole region right here, not under here. Well, it doesn't want to erase for me. I'm not sure why. Trying. This is not part of it, so it's above this line, which means that any point, so let's understand what this means. Any point within this triple shade region will satisfy all 3 of these inequalities. So I can randomly pick a point. Let's pick this point here. It's hard for me to see now. but I believe this is the point 3, 1. And if I put it into all of these, it should work. 3 is greater than or equal, or sorry, 3 is greater than negative 2. Works there. Why? 1 is greater than negative 1. So it works, negative 3. Ugh. And then here, if I put it in, I have y, 1 is less than or equal to 3/4 times 3 plus 2. Well, 1 is less than or equal to 9/4 plus 2. And you can see that 1 is already less than or equal to this because this is 2 1/4, this is 2, and 1 is definitely less than that, or equal to. Alright, next, you're going to be given some graphs to look at, and you have to come up with the inequalities for the shaded region. So I have this line right here, and I have this line right here. So I'll go ahead and work with this diagonal line first. So I can see that it's going to be y. My y-intercept is 0, and my slope, I rise 2 and run 1. So I've got the y and the 2x. I don't need the 0. I could put plus 0, but I don't need it. I do know it's going to have an equal sign under it because it's solid. And it looks like it's been shaded below that line because here's where the double shade is. So it's going to be less than or equal to 2x. This line right here is horizontal, so it's going to be y. It's dashed, so there's no equal sign. It's negative 1, and it appears that it's been shaded below. So y is less than negative 1, and that is my system for this graph. This one over here has 3 inequalities. The only way I can tell is because they made the x and y axis very thick for us, so we can tell. But again, I'm going to go ahead and do this diagonal line. So it's y. The y-intercept is 2, so it's going to be, I've got an equal sign or a half equal sign, and I've got a plus 2 out here. My slope appears to be 1. I rise 1, run 1. So 1x or just x. And again, this appears to have been shaded below the line, so that's going to be less than or equal to. I'll deal with my vertical line, which is x, and this is at 0, so x and then 0, since it's the x-axis, and it appears it's been shaded to the right, so it's greater than or equal to because it's a solid line. And then finally I have the y-axis, so that's going to also be a 0. It appears that it's been shaded above, so that's greater than or equal to 0. So here is the system for this graph. Okay, last one. The tickets for a school play cost $8 for adults and $5 for students. The auditorium in which the play is being held can hold at most 525 people. The organizers of the school play must make at least $3,000 to cover the cost of the set construction, costumes, and programs. So first they want us to go ahead and write the system. So again, I'm going to put money together. It's $8 per adult and $5 per student, and they want to make at least, so greater than or equal to, $3,000. Now I'm going to look at the total. It can hold at most 525 people. It can hold X adults, Y students, but less than or equal to 525 people. So there's the system. Now I need to graph it. I'm going to choose to graph this just like I did in previous sets using the x and y intercept. So here I'll go 8x equals 3,000. When I divide by 8, I get 375. So this is going, it looks like in hundreds. So 375, we'll say is right about here. And then I'll go 5y is greater than or equal to 3,000. So y is equal to 600. So right here, this is a solid segment, not a line this time, but a solid segment. So let's go ahead and draw this. And as far as the shading goes, it's greater than or equal to, so my shading is going to be up in here. And again, if you still want to check 0, 0, it doesn't work this time because 0 is not greater than or equal to 3,000. And then over here, my x is 525 and my y is 525 for the x and y intercepts. So 525 maybe right around in here and right around in here. And this time it's less than or equal to. So it's a skinny little area right here. Make it a little smaller. But if I do less than, I would shade below that line, so the double shading is going to be right in this portion here. Okay, if the organizers sell out and sell twice as many student tickets as adult tickets, can they reach their goal? So we need to figure out, they sell out, so they have sold all 525 tickets. So right here, 525 between the students and the adults. It says they sell twice as many student tickets as adults. So that means twice as many student tickets as adults. And we still have to do 525. So now this is equal to 525. So we get the student tickets, twice as many. Here's adults, here's students. Twice as many students as adults, so adults have to have the 2. And then this is less than or equal to 525. So we will have to see, can they reach their goal of the 3,000? So we would do this together with this one. And I'm going to challenge you to try to finish that one and see what you get. So here are your two systems, and when we discuss this, actually we will discuss the rest of this when you come back, or when I come back. So your assignment is going to be a worksheet 6.6. You don't have to start it tonight unless you want to, that's up to you, but you will have Friday and probably a little bit of Monday to work on this.